Okay, the definition of a function gives us certain characteristics of a function. Recall in the definition of a function, it assigns to each element in the domain exactly one element in the range. That means, number one, that each element in the domain must be matched with an element in the range. So you'll never find extra things in the domain of a function. Number two, some elements of the range may not be matched. So that requirement on the domain is not on the range. There could be other things in there. Number three, two or more elements in the domain may be matched with the same element in the range. So it's okay for multiple domain elements to go to the same range element. And the last one, 4, probably the most important, says that an element in the domain cannot be matched with two different elements of the range. And I mentioned that in the previous video. We'll never have an element of the domain having an arrow going to two elements in the range or more. Okay, so these are the characteristics of the function. Let's look at some examples of relations and determine whether that relation is a function based on these facts. So let's look at this first relation. This relation has 3 ordered pairs, so you can think of 3 arrows. 9 goes to -5, 9 goes to 5, and 2 goes to 4. All right, we can see here that we have 2 relations, 2 ordered pairs, that match 9 with 2 different elements of the range. So this value of 9 in the domain is matched with 2 elements of the range. This is not a function. Okay, let's look at the second example. We have -5 going to 3, 0 going to 3, and 6 going to 3. All right, so we have multiple inputs going to the same output. And that's okay. By property of 3 here, 2 or more elements of the domain, 2 or more, may be matched with the same element of the range. That's okay. We do not have multiple inputs or the same input going to multiple outputs. So this is a function. Right, we can also represent a relation with a graph. Now, a graph is just a bunch of points, right? And then we draw a line to kind of represent those points. So let's look at this example. Here we have a circle-like shape. Is this a function? Right. Well, we consider the x-axis to be the set of inputs and the y-axis to be the set of outputs. Here we can see that we have some domain, right? It starts about here and goes out to around here. So in these x values, there are a corresponding y. All right, but for some of them, say this x value right here, we can see that there are 2, one right here, one right here, outputs that correspond to it. So this x value has 2 output values associated with it. That means that this relation is not a function. And let's look at the 4th example here. We have a parabolic-like shape. These arrows mean that this curve extends out in this direction without end, and also in this direction without end, as do the arrows on the axes. All right, let's look at all the x values. Is there a value, an output value that's taken on twice? Well, if we start over here, and we'll have a point on the curve. If we go out further, we can imagine there's another point out there. Going in closer, we have points here, points here, points here, and so on. It doesn't look like for an x value there's multiple outputs. So we'll conclude that this is a function. Right, we can sum up a graphical test for a relation that we see on a coordinate plane, and that's called the vertical line test. So a relation that you see on a graph is a function if and only if it passes the vertical line test. No vertical line intersects the graph more than once. We can see with this circle that there are many ways you can draw vertical lines that intersect the curve more than once. For the example that we drew right there. So this vertical line intersects the graph multiple times. You can also visualize that on this fourth example. We can imagine a vertical line going through this, across this graph. It would never intersect the curve more than once. Therefore, this is a function.